All right. What we're going to go ahead and do today is our last module on collision detection. Now, there's a few things about collision detection. As you know, that it's something that makes or breaks a game, essentially, and it's where where a game can be more successful than others based on how you do your collision detection. And I'll give you an example: Angry Birds. Angry Birds uses a special type of collision detection, which and physics engine, which actually set it apart from every other 2D type game. And one of the common or the most effective collision detection for physics implementation, for if you hit on a certain point, it'll react appropriately based on the object itself, how it's shaped, the velocity, all kinds of different things, and basically making Angry Birds work the way it does, which is really cool. And that's the separate axis theorem. Now, the separate axis theorem, you guys can get into and look a little bit more into. It's a little bit difficult, and it's way, 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 way beyond the scope of this course. We would have to have quite a bit of prerequisites to actually get into that. In fact, actually, collision detection would be a whole course itself that you would take within more of a game programming type program. Like there's some there's a lot of them out there that recruit for the game developers that are always looking for new people. DigiPen, I know, is one of them that's local. So what we're going to do today is we're going to take our previously done particle generator, and here's kind of the direction I want to go for this. Is everybody wants to make some kind of projectile for their. Most people want to make some kind of projectile for their games. So what we're going to do today is we're going to kind of treat those particles as if they're bullets. And that's kind of actually how you would do a machine gun, is you would use your particle system. That's your machine gun, literally. So we're going to kind of, but I'm not going to really kind of, I'm going to show you how, basically we're going to write the code to detect the collision of a particle against a rectangle. And you can actually port this into your sprite code too. And then what we'll do is that function will just take a rectangle and see if any particular particle collides against that rectangle. And there's a lot of different ways to optimize. So I actually gave you a really cool advanced example, advanced mouse and collision detection code. Now this code is really cool because it does some more than just collision detection, because I've got a really cool way to deal with your basically the mouse. So let's actually look at that real quick. I'm going to get it loaded up, and then we'll talk about that code, and then we'll get into actually doing the we're going to do your assignment together today. So hold on, I'm going to bring up the code from the example collision detection, and then we'll get into it. Okay, so this is actually in the module for you to work with. It's underneath this advanced mouse and collision detection example code. So I built this to give you kind of a little bit more of an example on some advanced mouse usage and collision detection. And in fact, the collision detection I use is explained in this collision detection resource README. I believe it's this circle one. Yeah, it's that circle one. So that's the collision detection that the example is built on. And we're going to be doing a simple AABB check for our collision detection. So and it's called the axis aligned bounding box collision detection, AABB, axis aligned bounding box, and that's your simple the simple if statement check for a collision. And there's a lot of problems with that it causes, and maybe some of that will become apparent for today. But this example program that I built for the advanced mouse is this guy right here. It's called Shuffleboard, and what it does is it does a circle collision. But what's really cool is you can use it. You can grab a hold of your puck and pull back and then release. And then what it'll do is it'll go in that release direction, kind of like a pool, kind of like you set up a pool table game. I love it. It's just great. I had so much fun doing that. But as you can see, there's collision detection problems in here, of course. But oh my God, it's so cool. Okay, so anyways, you guys that one's for you, fun for you guys to play with. Let's get into what we're actually going to do today, which is not as complicated as this. However, feel free, this code is actually pretty good for making some physics decisions based on how things should bounce when the spheres are collided with each other. And it works fairly well. Of course, it could use a little bit more, a few more, of course, everything can always be better. Okay, so we're going to actually take this guy right here. And what we're going to do is we're going to just, what we want to draw a rectangle. And I want to draw a rectangle somewhere in here that's pretty small. And then I want these guys to bounce off of it when they detect it. And we may have to... this may end up having to reduce the amount of particles to make this happen. So first, let's deal with the rectangle. Let's get that drawing first, and then we'll go into the AABB code. I do believe I have this one. I'm going to put down there. This guy there's a good right here. This guy right here. This is the 2D collection or 2D collision detection that we're going to be dealing with. The axis aligned bounding box. I'm going to go ahead and just make sure that you know that this is for the above, for mouse. Okay. So the bounding box, that's what we're going to be dealing with. And this was really simple. It's just looking at the X and Y positions of two boxes. And if they are within the same, if one is inside of the other, then you've got a collision detection. And it's really a simple if statement that does it. So we're going to take this and we're going to use two rectangles for our particle. The first rectangle will be just basically the size of the particle. And then the second rectangle will be the square that we're going to be drawing on the screen. So let's go ahead and get the square drawing on the screen first, and then we'll go ahead and implement bouncing off of that square. Okay, so from your previous example, you should have had this code with your emitter. And in the emitter, it looks like we have some spray. And let me go ahead and zoom in on this for you guys. There we go. Okay, so first we want to just draw a box. And I think we're just going to make that static. But let's go ahead and create a rectangle here. And I always forget how to do a rectangle, and I always forget how to do rectangles in every language I work with because I work with 7 a day, so it's just horrible. I think it's just Google to the rescue. JavaScript rectangle. Rect method. Okay, so it's just a method. Okay, so we're just going to just draw it, but we need a rectangle with X and Y values. Is there a rectangle object? JavaScript rectangle object. Or is it just create a rectangle? Oh yeah, well, you know, I'm not gonna build a stupid rectangle object. No, let's just hard code it. Okay, so we'll hard code it with these values. We're gonna change these values, of course, but this is kind of what we're gonna be dealing with here. So let's go ahead and go back to our code. And I'm thinking too hard here. And our rectangle, we're going to have drawing before we update our spray, and we should be doing it. We don't need diagnostics. Let's get rid of that. The background is good. Okay. Okay. So now we're going to do context.rect and context.stroke, and then our rectangle, let's see if it draws. There's our rectangle. Okay, so let's go ahead and change where that's at, and let's go ahead for an X position of, let's say, I think that's 800 by 600, so it's going to be 700. And okay, that's that. Ooh, that's not bad. That actually is good. I want to bring it in a little bit more and down. So let's go ahead and do 650, and it's 800 by 600. So I need 300 here to be in the middle. And then I don't need it big. I just need it small. 50 by 50 is good enough, because we're going to be bouncing guys off of this guy. Okay, and then let's go ahead and fill it. Okay. Okay, okay. Well, you know what? That's good enough. I can bring it up a little bit, but I don't want to mess around with it anymore. Because the goal is just to get them to bounce off. So what we want is now we've got to actually build a function inside of each particle to detect on whether it's collided with a rectangle. Now, this is going to slow everything down super slow. This is where you either make or break your game with your if statements. The more you can get rid of, but hey, we got one we're going to be doing all the time for every particle. So optimization is a key fact, and in fact, we're not going to have this many bullets coming out of a machine gun unless it's a crazy machine gun. So we're probably going to have to reduce the amount of emitters we have for our machine gun first of all, and but let's build the function first. And this function is it's going to be part of the update of your sprite, and the update's already being called. So all we got to do is go in there and see, hey, did this sprite collide with this rectangle at this position? But that also means that we got to pass the rectangle down somehow to the sprite so that we know that it's looking. Because if we do it at the higher level in our project. At this level, which is in the game.cs, that means that we have to pass down the rectangle coordinates through the spray's update function. That means that we need to put in here, this could be an array of rectangles, or it could be, yeah, it could be an array of rectangles. And I would actually build a rectangle object for this, is what I would do. So this is where you would pass that rectangle object code, is into the spray update. Now we're going to go ahead and hard code it because we know where that is, but we're not going to hard code it totally. So let's go ahead and go into the particle code, and let's go look at this update. And what we want to do is we want to be able to send this the rectangle we want it to check on. But you know what? Instead of building a rectangle, we're going to just do an X, Y, width, height. And that X, Y, width, height will be our rectangle. And what you would do is you would actually you would create an object called rectangle that would have X, Y, WH, and that's what you would pass into this update function. You wouldn't do it this way. But I want to give you, you guys can put the time into that. And if you notice, there's the add to fix from the error from the previous module that is done for you here. Okay, so we just need to do an if statement with that X, Y, WH. And this is an update for each particle that is being called from the emitter code. So that means we need to send the emitter because the update function, if you see, the update function for the emitter needs X, Y, because this is your machine gun. The emitter.js you can call machine gun.js. X, Y, width and height, and then we just pass that directly down into each particle, so that each particle can check to see if it collided with the rectangle. Okay, I think we have everything we need. We just need to go into the update, and then we can finish. We're pushing everything down to our code in the particle. The only thing I need to do is make sure that I pass this information here. Okay, so that X, X, Y, width and height, that's going to be what each particle is going to be looking at to determine whether it should do something or not. All right. I think we're ready to go on. We're passing everything down. So the only thing we need to do is finish that if statement code in the particle, which what we want to do is we want to make sure that we check before we manipulate any velocity values. We want to check for a collision, because what we're going to do is if we have a collision, we're just going to reverse the velocity. And that's it. We're not going to get crazy on, how it should actually bounce. If you want to get into that, I got the circle collision example for you. And of course, that would require me to talk about math, which we can't do because we don't have the prereqs for this course. So we're going to get it working, and then you guys can use this as kind of your first intro into game programming, and you can get into the higher math and the collision detection, because that's what really is what makes your game. That's everything for the design. Yeah. All right, so let's get that bounding box access align bounding box code that we have as an example here, and let's just straight up grab it. We'll steal it. Okay, so this is the code that we're going to steal. And then we're going to go ahead and throw it in here and port it over to our code and see if we can't make these guys bounce. Okay, now rect1, that's actually our current values for, that's going to be our location X and Y. So we're in the particle, so it's going to be this dot X, this dot location dot X. Now, did I do the math vector? Did I call them X and Y? Yes, I did. Okay, good. All right, so let's go ahead and go back to the emitter code. Okay, so location dot X, so rect1 is our current particle, this dot X, this dot location dot X, and then it's going to be the other X, and that's just our X that we're passing in. So anything that's rect2 is just our regular WX. So rect1, that has to be ported into this. Okay. No, that's just okay, rect1 width. That's going to be particle width. That's going to be this dot width. Okay. And rect2, that is the other one. That's just going to be X. Rect1 Y, that's going to be this dot location dot Y. Rect2 dot Y is just going to be Y. Rect2 dot H, that's just going to be H. Rect1 dot H, there we go. That's going to be this dot height. And then rect1 dot Y, that's going to be this dot location dot Y. And rect2 dot Y is just going to be Y. Okay. So, that is the beginning. That whole thing is the if statement. On multiple lines. There we go. I just, I like things that way. You know how it is. Okay. So this means, something happened. And I absolutely hate this crap. Okay. Okay, so if there's no collision, we're just going to ignore it. We're not going to do a damn thing. But if there was a collision, what we want to do is we want to change and we want to invert the velocity of the particle. So this would be easy to do by, I think we may have to invert the acceleration and the velocity. So that would mean that this dot velocity dot x times equals -1. Just reverse it. This dot velocity dot y times equals -1. And then we need to do this for acceleration too, just in case, because we could reverse it and then have it just slow down. Or here's the worst part, it gets stuck in the other rectangle. That happens a lot, and that's one of the things that you're going to find out when you start playing with this a little bit more, because we're not going to get in. I'm not going to get into all those little gotchas. That's for you to kind of figure out on your own, and work towards as you're learning about collision detection. Okay, so this needs acceleration needs to be done. Times equal -1. Okay, this dot velocity. Oh no, acceleration. Acceleration dot y times equals -1. Okay, you know what? I'll dance a jig if this actually works. Am I dancing? Oh my god, I'm dancing. It worked. Look at that. Okay, just imagine me dancing a jig right now. But that's it looks like this one I did a fairly good job. There's not a lot of trapped particles happening. But you know, you would actually want to build an object for your rectangle. Actually, instead of having a rectangle check, you might want to send a sprite instead and look at X, Y. You know, you just need those 4 coordinates. That's all you need. You know, for the bounding box, axis aligned bounding box. So it looks like those guys are bouncing back as needed, and we have given you your first example of collision detection and how to implement a machine gun. You're ready now. You can take this emitter code and modify it a little bit and have it emit near one of your sprites for machine gun, and have it emit when somebody pushes the spacebar or something, and then detect if you've had a hit with your axis aligned bounding box code. Alrighty, that's it for today, guys. Thank you very much. I hope you enjoyed the whole course. Remember, collision detection should be a whole course. Alrighty, bye-bye.